write our parent points over here. And I saw a lot of people have been doing our like XY chart, like we were doing in the beginning of the year, which I love. So I'm going to get this going. All right, I think I'll get going. So if you guys have any questions, just yell or type them in the chat. Maybe Miss Boxon will be man in the chat while I do this.
Got it. I'm on it.
All right, so for all of these graphs, I like to start with the parent points, and x for sine and cosine, they're the same. So our x's are always 0, pi over 2, pi, 3 pi over 2, and 2 pi. And then the only difference is the y's to start off. So for sine, it goes 0, 1, 0, negative 1, 0. So I would just kind of always have this little t-chart somewhere, maybe on the top of your page to help you out. All right, so let's see if we remember what we're going to do. So inside the parentheses, inside the parent function, we've got x divided by 2. Does anybody know what we're going to do to the x's? See if we get anyone chatting on Zoom with us. Everyone's probably deep in thought. All right, so inside, I want you guys to remember.
Ooh, you divide by 2.
Cool. Since x is divided by 2, we're always going to do inside. We want to do the opposite of what's going on. So what's the opposite of dividing?
Hello, you all know the answer to that question.
I know it's early for us. We're going to multiply there. So just make sure inside is opposite. So x gets divided by 2, we multiply x by 2. So we're going to take all the x's and we're going to multiply by 2. It's going to be 6 pi over 2, which is 3 pi. And a lot of times you'll see a pattern. So at the beginning we had 0 pi, 2 pi, 3 pi, 4 pi, right? If we kept going, it'll go to 5. And that's it, we're all set. So these are going to be the x coordinates, and these are going to be our y coordinates. So now I'm going to put them on our graph. So we have 0, 0. My graph's kind of small here. You guys can rescale the y-axis if you want. So I'll make like this 1 up here instead of 5. And then we're going to pi 1, 2 pi 0, 3 pi, I'll go the same thing, negative 1, and 4 pi 0. And you can graph more if you want, but I say at least 1 period. So that's good for that one. All right, we got Destiny joining in, so I'll leave that one up for a second. But any questions so far? And hey, Destiny.
Hi.
Hi, Destiny.
Hi.
We just did number 1, so I'll make my screen a little smaller and leave it.
Okay, thank you.
I give number 2 a start here.
Happened, Destiny. You hit snooze too many times or what?
Yeah, pretty much.
We're just happy you're here. Nice crew today. All right, so remember, these are our key points for sine up here. Those are really good just to have for all of these. So I'm going to write sine key points. Our next graph, we need the cosine key points, but the x's are the same as the original for sine. And then my y's, instead of starting at 0, they're going to start at 1. So I go 1, and then I go to the midline, which is 0, down to negative 1, back to 0, and up to 1. So it's always either a 1.
So basically just the opposite.
Yeah, pretty much. We're like starting 1 point over. And I'm going to highlight these because they're good to remember. So these are our cosine key points. So those are good to have whenever we're doing these graphs. I would just have these somewhere for reference. All right, so what are we thinking? We have 2x inside the parentheses. Anybody know what we're going to do because of that? So we've got x times 2. What would be the opposite of that?
Divided by 2.
Divide.
Beautiful job. So we're going to really do x divided by 2. And it's only the x's that we do the opposite of. Anything else, so this minus 1 on the outside is just the same as it would be. So that would be y minus 1. So I'm going to write both of these new columns on here. We're going to do y minus 1. And we're going to do x divided by 2.
So divide by 2 and you subtract 1.
Right.
Pretty
We're
good.
subtracting 1 from
So
the
you-
y's, though.
You always take like the opposite.
If it's inside those parentheses, then you always do the opposite.
Okay.
Okay. And remember, another way to write this x divided by 2 is we could write it as 1/2 of x, which is a little bit easier for fractions, I think. So I'm going to go down the line and write our new points. So I'll have a 0, 1/2 times pi over 2, right, turns into pi over 4. We just multiply the denominator. And this guy will be pi over 2, 3 pi over 4, and pi. So this graph's going to be really smushed in here. And then I got to do my y's also. So that's a little bit easier. We're just subtracting 1. So 1 minus 1, 0 minus 1, negative 1 minus 1. All right, so I'm going to start graphing this. Another way I like to think about this one, where we did the y minus 1, is that's our new midline. So that means at negative 1, and again, I think I'm going to rescale the graph. So I'm going to change this negative 5. I'll do like 2 lines as 1. So on my graph, I'm going to actually put a dotted line. I'm going to put a dotted line at negative 1. You don't have to do this. I just like to, because of this negative 1 over here, to show me where the middle of my graph is. All right, and then like I said, this is going to be pretty small for points on here. So we have a point at 0, 0. Pi over 4 is half of pi over 2. So that's actually this line here. Pi over 4. Pi over 4, I'm at negative 1. Pi over 2, I'm at negative 2, which I said I rescaled my graph, but you don't have to. Let me get my color back. There we go. At 3 pi over 4, so that's just the next line. I'm at negative 1. And at pi, I'm at 0. All right, how's that graph? Is that making sense for us? Any questions? I know that one's, the scale is really small. I don't think we have too many others like that.
No questions here.
Thanks, Ms. Boxen. All right, guys, I'll leave that up here for a second so you can copy it. And I want you, maybe for the next one, to just start writing your little XY table to start. We have 2 things going on. We have a 3 on the outside, which will be 3 times the y's. And on the inside, we have x divided by 4 pi, so we're going to multiply times 4 pi. No, actually, I'm gonna get rid of the pi on the bottom. I shouldn't have had that guy. So we're just gonna change this.
No. Okay.
Yeah, we're just gonna change this to x over 4. So don't worry about that pi there. I'll go back and change the one online for those guys not here. All right, I'm gonna do the same thing. I'm gonna do my table over here for this one, so I have some room. And just give us a shout if you guys have any questions. All right, you guys still doing okay? Chris, you okay? Carrie, you good?
Yeah.
Cool. Allie and Destiny have their mics off, but just scream if you guys need some help or type in the chat. All right. This one, I didn't put any scale on the x-axis. So we're gonna look at these x points that we have. Looks like we've got 0, 2 pi, 4 pi, 6 pi, 8 pi. So I think I'm just gonna scale mine just like that. So it doesn't matter what you decide. I'll do like every 2 lines, I'll make 2 pi. And then just keep my pattern going. All right, and I'll graph my points in here. So I've got 0, 3, 2 pi, 0, 4 pi, I'm at -3, 6 pi, 0, and 8 pi, 3. So it's always the same curve. We've got like our valley and then our mountain. And you could keep, if you want to keep the pattern going, I would just go like another 2 more lines and keep going down to the bottom of the valley and then up back to the top. But as long as you have your 5 key points, I call it 1 period, then you're good. These graphs do go on forever though.
Mm-hmm.
All right, how's that going? Making sense?
Mm-hmm.
Yes.
Cool, thanks, Carrie. Chris, you're good?
Yep.
Cool. All right, so again, I'll like leave that one up here for us a little bit. And then our last 2, well, this one, I think we have the most going on for number 4. So let's see, did I do any more sines? Lots of cosines today. Our last one is a sine. All right, so I'm gonna start the T-chart for number 4, and maybe you guys just try that out too. We've got lots of stuff going on for this one. All right, so I got Carrie and Chris. Can anybody help me out? Anybody know what this 2 is going to do to our graph? Or Destiny or Allie?
You're gonna change the y.
Yeah, times 1.
Perfect. So if it's outside, we're going to multiply the y. So 2y. And how about this 1 on the end?
Add 1.
You got it. So we can do those. If you want to do them separate, you can, but I'm going to put them all at once. So it's going to be a 2y plus 1, right in the order that it is in the equation. All right, so
So you divide by 4.
nice, Chris. We're going to take the x's and we're going to divide them by 4. And I'm going to write that 2 ways, right? There's 2 ways we can write it. We could do x divided by 4 or 1/4 times the x's. And I'm going to write my new points out here. So 0. So 1/4 times pi over 2, we just multiply the denominator. So we get pi over 8. And then pi over 4. 3 pi over 8. And this would really be 2 pi over 4, which is pi over 2.
I got the y. 3, 1, -1, 1, 3.
3,
Right.
1. Say it one more time. 3, 1, and then negative
-1,
1.
1, 3.
3. That sounds beautiful. Nice, Chris. All right. Now again, we have to mark our own scale. So I would just use exactly what we have over here for our x coordinates. And these are always the same distance apart. So like, for example, if I say, okay, this line is going to be pi over 8, then that same spacing. So I have 2 lines right here. 2 more lines would be my next one, pi over 4. And that's really 2 pi over 8. Which is kind of tricky to think about, but they'll always be evenly spaced. So this one would be 3 pi over 8. This one would be 4 pi over 8, which is pi over 2. You don't have to mark every line. Like I didn't write 3 pi over 8 in there. Maybe I'll just try to make these a little bit smaller. There we go. All right, and then I'm just graphing my points in here. So 0, 3, pi over 8, 1, pi over 4, negative 1, 3 pi over 8, 1, and pi over 2, 3. And like I was saying early on, I like to graph this plus 1 is also the midline of the graph. So that tells you where the middle of your graph should be. So my mountain should go over and my valley should go underneath. So if I keep graphing this, I would go to the midline and then down to the midline. Again, you don't have to graph more points, but that would be kind of what your graph, what they call it, oscillates above and below. All right, cruising right along. Any questions so far?
I think we're pretty good
No.
on things.
Or Destiny said no, we sound good. Carrie's good. Chris, did you have a question or you're okay?
Okay.
Cool. All right, so we got one last one. I'm going to have you guys give it a try. There's one difference here. Does anybody know what this negative out front might do?
Flip it.
Flip the
Yeah,
graph.
it's going to flip it. So it's going to be a negative when we have our x, y's. It's going to be a negative in the y column. And since it's with that -2, that's exactly what's going to happen. It's going to be -2 times the y. So just like Carrie said, that's going to end up flipping our graph. So in your t-chart, we'll have -2 times the y's. Anybody know what's going to happen to the x?
inside parentheses, what happens if it's inside?
What do we think? We've got a 3 times x in here. Any
Oh,
thoughts?
it becomes 1/3.
Yeah, nice
Yeah.
job, Destiny. We can write it as 1/3 times x. That's the same thing as x divided by 3. So whatever one you guys like.
Yeah.
All right.
Why
This is the sine graph now.
Peaceful.
don't you put your books up here? And do it down like this. Okay? Keep it going. Oh, you want it? Finish it around this. It's stuffy, no? Is it kind of stuffy?
All right, so I'm going to leave that one there. You guys can try at your tables. I'll give it like a minute or two, and then I'll graph mine and see if we all match up.
For the y part, I got 0, -2, 0, 2, 0.
Nice work, Chris. That sounds great.
Multiplying.
How about you have your x's too, Chris?
Hmm? Yeah.
You get the x's too. I'm going to start writing mine in here. So we'll have 5 here, 5, 3. And for these x's, if you guys ever want to get a common denominator, I know it's a little bit extra work. My screen's going a little crazy here. Well, that's where we'll see the pattern for these. So this would be pi over 6. If I got a common denominator for pi over 3, it would be 2 pi over 6. So here's our pattern. Pi over 6, 2 pi over 6, 3 pi over 6. This guy would be 4 pi over 6. So some people like to write that better on their graphs, but as long as your points are good, I'm okay. All right, and then I'm going to graph these guys on here.
I just have a quick question.
Sure.
So for whenever you you multiply like the pi and then like the x, like how do you do that? Because
So-
whenever I try to type in my calculator, it's like a different answer.
So don't even type the pi in your calculator. So if we're doing like this one, if we're doing 1/3 times pi over 2, because your calculator will like round pi. So I would just do 1/3 times, like in your calculator, just do 1/2 and then put the pi in at the end.
Oh, okay.
And still the calculator, if it might not even give you the fraction. So I would just do it like this. So we know 1 times pi is pi, and then 3 times 2 is 6.
Okay.
Yeah.
Yeah, because pi over 2, Destiny, is the same as 1/2 pi.
Yeah.
Like x over 3 is the same as 1/3 x. So just focus on like the numbers and leave the pi kind of out of it.
Okay. All right. Thank you. Because I was like getting like random numbers. I was like, okay, what?
Yeah. Those numbers would be right. They'd just be really annoying to graph because they're big decimals, right?
Yeah.
Yeah. All right, I'm going to graph my points on here, and then we'll make sure we all match up. Let me highlight the ones I'm graphing, so it's not as confusing. All right, and if you notice, for this one, we're going down into the valley first instead of up to our mountain, which is the opposite of our original sine graph. So that's the reflection that Kiri mentioned before. And then we're all set. And again, I like to draw the arrows on the end just to show that it does keep going forever. All right, how are you feeling? Any questions?
Right, but all right. You said once we're done with the worksheet, we can turn it in. You have to take a
So
photo
you
of it.
take a picture of it and post it on Google Classroom.
Mm-hmm.
And then you're all set for today.
All right.
Mm-hmm.
Thank you.
No problem,
Thanks,
Destiny.
guys.
Good job.